Hello everyone, welcome to this video. In this video, let's look at another question. So in this question, they are asking we need to describe the symmetries of a non-circular ellipse, and we need to also describe the symmetries for a hyperbola. So let's get started and solve this question one by one. So first of all, we'll see the symmetries for an ellipse. You know what is an ellipse, what is the shape of an ellipse. We have an ellipse defined by like this. Here, just for the purpose of telling you about symmetries, I am labeling these four positions as A, B, C and D, right? So here we can define the rotations as well as the reflections as its symmetries. First of all, if we take the rotation by 0 degree, that means we are not doing anything to it, so it would remain the same. So this is one of the symmetry which forms the identity here. For the next one, if we take the same ellipse and we rotate it by 180 degree anti-clockwise direction. So we are applying our 180 where we are rotating it by 180 degrees in the anti-clockwise direction. So what would happen to A? A would come to the position of C, D would go to the position of B, C would go to the position of A, and B would go to the position of D, right? This is what we are doing, and hence we have this ellipse with us as the final answer. And if you see the shape of it, it's just the same, right? So this is one of the symmetry. Let's move ahead, and these are just the two rotational symmetries. We cannot have more rotational symmetries here, because if you rotate it by 360, that is equivalent to taking R0, and there is no angle in between 360 and 0 apart from 0 and 180 for which it shows symmetry. You may check. So after having these two symmetries which are due to its rotation, can we have any symmetries by its reflection? So the answer is yes, we can have symmetry about this horizontal axis and the symmetry about the vertical axis. If we take this horizontal axis here and reflect it, taking it as a mirror, if we reflect this particular ellipse, what do we have? This A would go to the position of C, and this C would go to the position of A. B and D would be unchanged. They would be kept at their own position. So you see, the shape does not change here. So we have symmetry of this kind. And when you take this vertical axis here and take this to be the mirror, so what would happen? To this, B would go to the position of D and D would go to the position of B. So the shape would be the same, however the positions differ. So here in this case also we have reflection symmetry. So in total we have two rotations and two reflection symmetries here according to the explanation that I have given to you. Hence we have R0, R180, H and V as the symmetries for this non-circular ellipse, right? Now what about a hyperbola? If you remember what is a hyperbola, it is a bow-like structure where we have the y-axis which is our vertical axis. So this hyperbola looks like the mirror image of itself. So you see here, if you rotate it by 0 degree, we would have the same hyperbola. For the purpose of illustration and for understanding, let's label this portion as A, this as B, this as C, this as D. So we would have the same hyperbola when you rotate it by 0 degree. So this is the identity here. Now we can also rotate it by 180 degree. If you rotate it by 180 degree, what would happen? This A would go to the position of C with the same image, right? And this portion would go to the position of D, and with it is also like this. In this manner we can draw it. So when you rotate it by 180 degree, you would have the same hyperbola. However, the positions of A and C would be exchanged. The positions of B and D would be exchanged, right? So this is what we are doing here for rotation, because A would go to the position of C, B would go to the position of D, C would go to the position of A, and D would go to the position of B, and this is what we are doing. So this is the same thing as we have done for this ellipse. We can now also have, these are the two rotation symmetries. We can also have reflection symmetries here. For reflection, we can take this horizontal axis. Now along this horizontal axis, if you take the reflection, we would have the same hyperbola back, right? For the purpose of illustration, this particular arm would come to this particular arm, so that means A would go to the position of B and D would go to the position of C, and vice versa. For vertical axis, if we take this vertical axis, so what would happen? This arm would exchange positions with this arm, so giving you back the same figure. So this D would go to the position of A would go to the position of D. Similarly, B and C would exchange places. So we have the same hyperbola with just the few things exchanged. However, the shape would be the same. Hence, in this case, R0, R180, H and V, they form the symmetries of the given hyperbola. So hence we have the same symmetry group for both the ellipse as well as hyperbola. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.